Welcome back. Section P1. So our section P's, or chapter P, is going to be the pre-calculus. So it's a little review of what we did last year, and these kind of the main points that I want you to take away from pre-calculus so that you're ready to tackle in on the calculus, and we'll use a lot of these things throughout the year to just give you a better understanding, hopefully, of what we're working with. So P1 talks about symmetry of graphs. Remember, there's three types of symmetry that we talked about last year in pre-calculus. We talked about y-axis symmetry, origin symmetry, and x-axis symmetry. If I have y-axis symmetry, that means that if we have a point xy on any graph, then also the point negative xy is going to be a point. And the way we can test that is by showing that f of x is going to equal f of negative x. So if we replace our negative x with all of our x's, we should end up with the same function back. We also call this an even function. Very important that we understand that even function goes along with y-axis symmetry. And you'll kind of see why that is in a little bit when we talk about our polynomials that have even symmetry. Symmetry about the origin allows us to flip it around a point or rotate it around a point, 0, 0, the origin. And here, if we replace the x with negative x, we're going to end up with the negative of the function. So here I have the point xy. Another point on that graph would be negative x and negative y, which would correspond to that point. We call this an odd function. So even functions are symmetric about the y-axis, odd functions symmetric about the origin. The way you can think about that is O and O. Origin starts in odd, start with the O's. And the point 0, 0 as well. Let's see, x-axis symmetry. This one, we're going to see that it doesn't relate to functions. And if you look at the graph here, of course it's a sideways parabola. And we know a sideways parabola doesn't pass the vertical line test. So it's not going to be a function. However, if we replace the y with a negative y, we'll get the same x value. X-axis symmetry, not as important, not as used as the even and the odd functions are as we work with our calculus. X-axis symmetry is still there, but not as prevalent, because we normally talk about functions and not necessarily the x-axis symmetry. Well, we will a little bit. So, how do we test? Remember, we're going to replace the y with a negative y. Oh, sorry, that was with the x-axis. Replace the y with negative y to see if you get the same function out. So, for example 1, we have y to the fourth equals x squared minus x to the third. We're going to test for all three symmetries for all of our problems. So to show you how it works. I may ask you to check for y-axis symmetry. I may ask you to check for x-axis. I may ask you for the origin. I may ask you for all three. Just kind of depends on how the question's asked. So example 1, we're going to test for all three. So the first thing I would do would be find f of negative x. And this is going to test for the y-axis and the origin all in the same time. So if I have f of negative x, our y to the fourth is going to stay the same. And that's going to equal, I guess we'll do f of negative x that way, y to the fourth equals negative x squared minus negative x to the third. Now we're going to simplify this to see what we get. Well, here we have y to the fourth equals negative x squared is going to give us an x squared minus, here, minus a negative gives us a positive x to the third. So we should see here that x squared plus x to the third, which is our final simplified form, is not equal to x squared minus x to the third. So this is not even, and it's not odd. Now, if we want to get into the x-axis symmetry, here we're going to replace the y with negative y. So y replaced with negative y. So here we're going to get negative y to the fourth equals x squared minus x to the third. Now I can go ahead and get negative y to the fourth. Negative y to the fourth is y to the fourth. That equals x squared minus x to the third. Notice here we get the same exact thing out. So this is symmetric about the x-axis. And that's the only symmetry we're going to have with this example. So we're going into example number 2. Y equals the negative of x squared plus 4. again, we can find f of negative x. So we're going to have y is going to equal the negative of negative x squared plus 4. So y is going to equal the negative of, well, negative x squared is simply x squared, so we have the negative of x squared plus 4. So we see that this problem is the exact same problem here, or exact same answer. So we know that this is symmetric about the y-axis, or an even function. In order for it to be the origin, we'd have to get exactly the opposite out. Not exactly the opposite, so we know it's not an odd function. The other ones, we replace the y, negative y, with y. So here we get the negative of y equals negative x squared plus 4. That, if we solve for y, we get y equals x squared minus 4, which is not exactly the same. So we know that it's not symmetric about the x-axis. And we already talked about it's not symmetric about the origin as well. All right. And I think I got one more example here for us. We have x squared plus y squared equals 4. Well, hopefully we recognize this from our days in Algebra 2 and Mrs. Gunn and whoever else you may have had for Algebra 2. X squared plus y squared equals 4 is a circle. So again, we're going to find f of negative x. So here we have the negative of x squared plus y squared equals 4. So we have x squared plus y squared equals 4. So that is the exact same as x squared plus y squared equals 4. So we know that this is symmetric about the y-axis. All right, we can go ahead and find our y and negative y replacement. So here we've got x squared plus the negative of y squared equals 4. So here we get x squared plus y squared equals 4. Those are exactly the same. So then we're symmetric about the x-axis as well. And then the origin. Well, if we think about the origin here, we know that f of negative x is going to equal the negative of f of x as well. So does that work with this one? And since this isn't a function, it kind of doesn't play into what I talked to you about earlier with finding f of negative x. So in this case, we actually have to take our x and replace it with negative x and our y with a negative y, since x squared plus y squared is not a function. If it were a function, then we'd be able to test it up here just like we did before. Replace your x's with your y's to be able to see if we get the same thing out. So if I do that, then we have the negative of x squared plus the negative of y squared is going to equal 4. So we get x squared plus y squared equal to 4. So this gives us the exact same thing out, so we know that it's symmetric about the origin as well. So if we think about it, our graph here, x squared plus y squared equals 4. It's going to look like a circle here. So we should see that at any point over here, our xy value is the same as negative xy. Our xy is the same as negative x negative y, and xy is the same as x negative y. So all three symmetries are going to hold. So talking about the even and the odd functions and that sort of thing, even functions, you're going to look at your exponents and it's going to give you an idea if it's going to be even, odd, or maybe even neither. So notice here we had even exponents, so we see it was symmetric about the y-axis. We also saw that it was symmetric about the origin in this case. In example 1 there, notice that we saw a combination of even and odd exponents, and we found that it wasn't even nor was it odd. And then, with example 2, sorry, I lost where I was at. In example 2, notice we saw that we had an even exponent in it, within our x's, and we saw that it was symmetric about the y-axis, and we called that an even function. But it wasn't symmetric about the origin or the x-axis there. So some couple things to look for if you are paying attention, and you can kind of look at the way the polynomial is set up to whether it's going to be an even, odd, or possibly neither, but make sure you do test for those symmetries. Happy symmetrying. Is that a word? I think so.